Food security is one of the sustainable development goals that we need to focus on nowadays, according to the United Nations Development Program 2015. However, pest infestation is still one of the main challenges that needs to be addressed in our farmers' situation. Pest management systems could significantly affect their capacity to increase their harvest and food production capacity. In the context of the Philippines, diamondback moths are known as one of the most destructive pests of the crops, while the Eurasian tree sparrow is recognized by farmers as a serious pest to their rice fields. Currently, our farmers are utilizing existing technologies regarding pest management systems. Many farmers are putting scarecrows and using frightening sounds like gunshots or firecrackers to scare away the birds and prevent them from feeding on the grains. They are also installing Tide cans or plastic bags at the rice fields and spraying chemical insecticides within the area that could pose environmental problems. On the other hand, the potential of renewable energy sources is enormous as they can meet the world's energy demand. Renewable energy sources such as biomass, wind, solar, hydropower, and geothermal can provide sustainable energy service. In the Philippines, the utilization of solar and wind energy is one of the most significant aspects to promote clean and affordable energy for the people. An average of 161.7 watts per square meter of solar radiation can be converted into electricity using a solar energy conversion system, while the energy from the wind with an average wind speed of 4.66 meters per second can be converted using a wind energy conversion system. From all of this, our team proposes Project SWAT, or Solar and Wind Powered Agri-Pest Trap Peller. Project SWAT integrates the principle of wind and solar energy conversion systems to the problem of pest management in farms. Using a combination of 300 watt solar panel and 18.2 watt Savonius wind turbine, the system can produce up to 1.94 kWh of clean energy per day. This energy will be used to power the control systems, ultrasonic bird repeller, and UV bug zapper to act as the pest management system of the farm. Overall, the system consumes 1.77 kWh of energy per day. To further explain the flow and the construction of the system, in this project, the innovators will utilize a 2-inch metal pole to act as the main mounting mechanism where the bug zapper, ultrasonic bird repeller, control panel, battery, solar panel, and wind turbine will be mounted. The pole will be buried 3.5 meters below the ground and will carry the whole system. For the power generation, two 150 watts monocrystalline solar panels mounted 2.7 meters above the ground with an A-shaped frame and a vertical axis Savonius wind turbine with a height and diameter of 1 meter mounted 3.7 meters above the ground will be used as the system's energy sources. The electricity produced by the wind turbine will go to the wind charge controller, which consists of an AC-DC converter and DC voltage regulator. On the other hand, the electricity produced by the solar panel will go to the charge controller. The output of the charge controller will then charge up the 250 ampere deep cycle lithium-ion battery. The stored energy on the battery will be used to power up the system. Using a light sensor, the ultrasonic bird repeller automatically activates during the day where most of the birds are feeding. It will be mounted 2.5 meters above the ground. The ultrasonic bird repeller is composed of a 555 timing circuit which determines the duration and interval in which the ultrasonic buzzer produces up to 25 kHz ultrasonic sound wave in 4 orthogonal directions. The ultrasonic waves will deter the bird activity within an area of 1 hectare. Using the same light sensor, the UV bug zapper automatically activates during the night where the light trap is most efficient. It will be mounted 1.5 meters above the ground, which is the ideal height for a light-based insect attractor. The bug zapper will utilize 4 40 watts ultraviolet bulbs to attract moths and other insects within an area of 1 hectare. Upon attraction of the moths and insect, the electrocuting cage made up of 2-layer cage with a 2000 volts potential difference that surround the ultraviolet bulb will electrocute and kill the pest. The outer cage of the electrocuting cage will be connected to the ground to ensure the safety of the user, while the inner cage will be connected to the Cockcroft-Fulton generator. And unlike traditional light traps, this system utilizes high voltage to vaporize the PECE for minimal cleaning and maintenance. Through this construction and design techniques, the Project SWAT or solar and wind-powered agri-pest trap peller can be installed on farms that needs a pest management system easily and protect the farm against bird, moth, and other insect infestation within the area of 1 hectare. The result of Project SWAT could have a positive outcome for the agricultural community as it gives more selection to their way of controlling pests in their farmlands. It can also promote sustainability as it utilizes clean and affordable energy. Hence, Project SWAT does not only offer clean and affordable energy but also a cleaner pest management system. Our team is looking forward to working with you in achieving this project, and together, let's pave the road for a cleaner and prosperous tomorrow.